Phew. Okay, so welcome everybody to the official first class of Math 1730. I mentioned in yesterday's class that this is a combination of mathematics and a little bit of chemistry. You don't need to know anything really from previous courses, not really. The chemistry part comes in because we're going to be dealing with concentrations or masses of pharmaceuticals. So we might be talking about the concentration of a solution in parts per million. We might talk about the milligrams of medication in a pill. So there's a little bit of chemistry here in terms of like grams, milligrams, milliliters, liters, parts per million. We won't really talk about moles like we did in chemistry. And then, of course, there is some mathematics as well. For anybody new, this is not a long course. This is a really nice course to do in intercession. So I think we're going to have as much fun as people can have in math. I personally love math, but I'm a weirdo. So you can see my screen here. This is the first page of your notes. And let me just go back for 1 second to my D2L. Sorry. Your notes, and this is really important. It's up to you. You can print this if you want, but these are your notes. Like, this is what I'm going to go through in class. Everything else is review or practice. This is huge. I highly recommend, if you can, to print your notes. You can come to the college and find a place to print them. I think maybe you have a printer at home. And like, guys, if you don't own a printer, like I don't own a printer, don't worry. What I would do is, as you know, I'm teaching, maybe have a piece of paper, a little booklet or something, so you can write, Unit 1, Topic 1. And then you can write down, some practice questions or something like that. So you don't need to print, but it would be nice. I do not own a printer, so I'm not surprised if you guys also don't own a printer. Whoa, sorry. So, whoops. I'm definitely not used to this yet. I'm used to using PowerPoint, but math doesn't really work very well for PowerPoint. So just kind of bear with me a little bit here. All right, but as you notice, I can write on the screen. And the cool thing about Adobe is the writing stays where I put it. So it's a little bit easy. Okay, the metric system. So anybody who's had me before knows I love the metric system, or the SI system. The SI system, it stands for the International System. So if you remember from Chemistry 1120, if you've done that course, if it stands for the International System, why is it SI? Well, it's French. System International is what the French means. This is a global measurement system used everywhere except the US, because they're crazy. They use like the imperial system. They would use like pounds and quarts, which we will actually look at in this course. We're going to look at ways to convert American numbers like PSI, or I guess fluid ounces, to metric units like milliliters. Okay, most places use metric. If you've ever heard of the number parts per million, that's basically metric. It's grams per milliliter, and they're both metric units. So in Math 1700, I'm about to do this with my Math 1700. You guys already did this. You converted between metric units. You've done this. So we're going to look at this again, but here's the thing. In pharmacy and everyday life, you're only most likely to see the most common of the metric prefixes. What do I mean by that? Well, in everyday life or pharmacy, you might see centi or milli, so like milligrams or centigrams. In real life, in everyday life, you might see kilo, kilograms, like when you are buying like vegetables or chicken at Monoprix, they might be measured in kilograms. Typically in pharmacy, you don't measure in kilograms unless you're weighing a person. So a person's weight would be typically recorded in kilograms, whereas in America, it would be pounds. But for units of measurement in pharmaceuticals, so you're talking about pills or ointments or solutions, medications in liquid form, you would use milligrams, centigrams. You might even see parts per million. And a lot of you guys might think, well, ppm, that doesn't look like it's on this list, but it actually is. It's grams per milliliter. So this is a bit of a review. This is kind of a good place to just do a warm up today. Do you guys, okay, so I have a question. Do you guys remember this from chemistry and math? You would have done this in chemistry 1120 or math 1700. Anybody remember this? Yeah, Abdullah 1700. Yeah, so Abdullah in chemistry, this was done very, very quick, because in chemistry, it would have been like grams to kilograms or liters to milliliters done, right? We didn't do a lot of this in chemistry, but for Abdullah and Kalsum, you say you remember this, it's probably more from 1700. So, this is actually good. It's a little warm up really of it's review. It's review. Let's keep it simple. So in a pharmaceutical industry, and actually guys, I have a fun fact for you. When I was, I'm old. Well, I'm not that old, but I'm 36. So in 2003, I started university or college, same kind of thing. And I was actually studying or was going to try to do pharmacy. I started what they would call in Canada pre-pharmacy. So pre-pharmacy, you would do chemistry, biology, physics, math, and then an English course or language course. So my first 2 semesters, I did like chemistry 1, physics 1, biology 1, and then math 1. Second semester, chemistry 2, physics 2, biology 2, math 2. And I was all ready to apply to pharmacy. My best friend in the world, he still lives in Canada. He is a pharmacist right now. He works at the hospital in one of the biggest hospital in Newfoundland, where I'm from. He's a pharmacist. Me and him were going to apply. And I just and I know this sounds really cheesy, but I liked chemistry so much. I said, you know what? I'm going to stick with chemistry. And I have some regrets. Pharmacy is a really interesting field. There's a lot of demand. There's lots of job opportunities for pharmacist technicians. Not a lot of demand for someone with a chemistry degree, but anyways, I ended up teaching, which is one of the best jobs I ever had. But fun fact, if you're curious, when I graduated high school, I wanted to be a pharmacist, and I just really fell in love with chemistry for some weird reason. So back to pharmacy. Different from chemistry, different from physics, in pharmacy, there's a few numbers that you're going to deal with a lot. The weight of something. This could be the kilograms of your patient, right? Medication is delivered based typically on mass. So like a large male patient, 100, 120 kilograms might need more medicine than somebody smaller, like that's 70 kilograms or 60 kilograms. So you'll hear about, and then, so the mass could be the kilograms of the human, your patient, or it could be the milligrams of medicine, the chemical compound that's, like, for example, paracetamol. It could be the milligrams of that. Volume is really important in pharmacy. You're going to be measuring volumes of chemicals when you're making ointments or you're making solutions that people would drink. And then there's length. Length is just good to know in life in general, but length could be, different sizes of different medications you're giving, things like that. So in pharmacy, like in science, you would look at moles and lumens and electricity and all these different units. In pharmacy, we're talking weight, volume, length. All right. So, first of all, let me explain. Let me just go up a little bit. This is your conversion cheat sheet, and I can give you guys this on your test. Okay. And the reason I don't mind giving this to you is because, in real life, you're going to have a calculator, you're going to have a phone. Google can do most of these for you. The way it works is if you were going from your base unit, so this is your meter, your gram, and you're trying to convert it to, say, kilograms, you would go this way. You move the decimal to the left or you divide. And every factor here, or every number, is a factor of 10. So this would be, a DA, not really one we would use in pharmacy, but kilo for sure, centi and milli, definitely ones we would use. So in pharmacy, these are the ones you really need. Well, maybe not giga, but kilo, centi, milli, and yeah, actually micro you might get to as well. Nano, maybe not, but yeah, you might see micrograms as well. So kilo, centi, milli, and micro. And we're just going to practice how to convert through this. So let me check the chat and we'll do some practice problems. I got a nice message in the chat there. Yes, hopefully you guys will go on to be pharmacists, farm technicians. The only reason I didn't do it is just because I really liked chemistry. I don't know why, but one of the best parts about being a teacher, and this is just, I got a private message that I'm responding to, is even if I don't get to be a pharmacist or an engineer or a medical science, lab tech, I get to train them, kind of, at least in the first courses. Okay, so it says convert each of the following measurements by moving the decimal place. Now, I'm not a big fan of just moving the decimal place. I like dividing or multiplying, but we'll kind of look at this in general. Sorry, just 1 second there. Hold on 1 second. Okay, sorry. So let's look at the first one. Pretty classic chemistry question, or like 1700 question. I want to convert 1 liter to milliliters. What I'm trying to do, is I want to draw that first thing on this page so we can do this together. Just give me 1 second here to open something up. Okay. So I'll draw this here. So we have our base unit. We have, give me 1 second. It's not very entertaining for the recording. I'm just trying to get something else open for myself. Hold on, almost there. So close. My computer is being so slow today. And I don't know why. Hold on, man. Something like I had a big problems in my class this morning with the internet as well. So it's just loading here. 1 second. All right, cool. So we have DA, deca, you won't see that a whole lot. We have H is hecto, you won't see that a lot. And then we have K for kilo. Here we have D, small d, this means deci. You won't see that a lot, but here we go, centi and milli. And there is some more after that. Okay, so I want to go from milliliters to liters. So I'm trying to go from, let me change my color. I'll go with blue. I'm trying to go from milli all the way to my base unit of liters. So I'm moving 3 places to the left. This means I'm going to, for my number here, I'm going to add 3 decimal places. So because I'm moving back this way, I'm going to add 3 decimal places to this. So 1, 2, 3. So this becomes 1,000 milliliters. Not typically how I would do this, because in math or in chemistry, I would just multiply this number by 1,000. Okay, does that make sense for everybody? Okay, after milli is micro. Oops, sorry, I meant to pick red. So let me pick my red pen here. I got a lot going on in the chat. Hold on. I'll read that in a second. And after kilo is mega, giga. You probably won't see giga. Nano. Okay. Let me check the chat and we'll look at another one. Everybody good? Everybody good? Okay, so Abdullah asked a question in the chat. Why do we go left? So if you, I love PowerPoint sometimes. The way that it works, it's kind of like the opposite of what you would think. So when I'm going from, say, let me clear this. When I'm going from this number back to this number, I'm basically multiplying it. Like like the number is going from what was it, liters to milliliters. The number is getting bigger. So we move the decimal right when you're converting on this side of the graph. We move the decimal left when we're converting on this side of the graph. It's a little bit backwards than what you think, but the idea here is when you're going, let me clear my writing again. When you're going in this direction, the number gets bigger. When you're going in this direction, the number gets smaller. We'll practice this. You'll see. I hope you'll see, inshallah. All right, let's look at the next one. So milligrams to micrograms, 1.2 milligrams to micrograms. So this is times 10 to the minus 6. This is times 10 to the minus 3. So milligrams to micrograms. This is this one is a little bit challenging, I guess. We're trying to go from a factor of milli to a factor of micro. And the difference between these is 1,000. So going from milligrams to micrograms, I would take 1.2 milligrams to micrograms. That little u means micro. I'm going to move my decimal place 1, 2, 3. 1, 2, 3. And you would get 12,000 micrograms. All right, do you guys remember this from 1700? Maybe, why don't you guys try some of the easier ones? Why don't you try number 3 and 5? These might get you warmed up a bit. Why don't you guys try the answers for 3 and 5 and see how you do with those, and then we'll check your answers. And somebody just sent me a private message. It says from right to left divide, from left to right multiply. That was just sent to me, but yes, you're correct. I'm going to try to share something with you that might explain this a little bit better as well. The notes aren't very explanative here. So I'll give you guys a minute to try 3 and 5, and I'll be right back. Oh, sorry, I had an extra 0 there on mine. I didn't mean to do that. It's because I'm writing on my screen. Anyways, I'll explain that in a second, but try 3 and 5. Sorry, I'm muted. I got something I'm going to share with you. Like these are the math department's notes. Keep working, but I'm going to share something with you in a second that might help a little bit better. Keep working. You can try some other ones too. Yeah, I don't know why this one isn't in the notes, but anyways, I'm going to show you something in a minute that might make a bit more sense. Check the answers here. Yeah. It looks like I'm getting good answers in here from Abdullah, from, is it Lolo or Lolwa? Lolwa. All right, cool. Awesome. Asma, good answers. And again, if anybody's confused, I think the notes are really missing something. So I'm going to show you something in a minute. And what I'm going to show you is something I'll give you on your test. I really think the notes kind of let you down here. This will make a lot more sense in a second. All right, so I got a question from Kalsum. All right, let's look at the answers. I'm going to clear my screen, and I'm going to show you something that will hopefully make this a little better for you. There we go. Okay, so have a look. I'm going to try something a little interesting here. Okay, share my screen. This will make your life a lot easier. If you can see my screen. Okay, don't worry about the bottom, but this is a complete version of that line. This is what your note should say. I will give this to you on your test. Now, let me try something here. And then now this should hopefully explain the problem a little bit more. I just think the notes are like missing some units. So just give me 1 second. I'm going to try something sneaky. Okay, almost done. You'd think I'd be like really fast at my computer now. Okay, I'm going to try something new. I'm going to share my entire screen. So you guys should see in front of you the practice problems, and then you should see the number line up top. Okay, so let's look at these. So let me just show you number 2 again. I'm going from milligrams to micrograms. So 1.2. Okay, I'm going from milli to micro. 1, 2, 3. To go from milli to micro, I need to go 3 decimal places. So 1.2 becomes 1, 2, 3. Oh, sorry. Anybody who's had me last term knows my pen likes to mess with me sometimes. So 1, 2, 3, decimal, 0, 0. Okay, micrograms. All right, let's look at the other one. Okay, number 3. Okay, so I'm going from meters. Now, meters is my base unit, so meters, to centimeters. 1, 2. So I move my decimal from 1 meter. I'm going to move my decimal 1, 2. So it becomes 100 centimeters. Okay, does that make more sense? Look at number 4. 4 nanograms. Well, I'm going to have to do this a little differently. I'll put my 4 here. Here's my decimal. Okay, look at nanograms on my map. Or look, sorry, you don't have to look at nanograms. Look at nano. So here's nano. 1, 2, 3, 4, 5, 6, 7. Ooh, that's pretty ugly. Sorry. Try that again. Make it look pretty. 1, 2, 3, 4, 5, 6, 7. I'm going to go back 7 places. So 1, 2, 3, 4, 5, 6, 7. I know I didn't ask you guys to do this one. So this would be 0, 0, 0. I just want to make sure I'm counting right. 0, 0, 0, 4 centigrams. Now, guys, number 4 you would never see in real life. Never, never, never. All right, let me check the chat, and we'll do a couple more. All right, Kalsum, good, 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 good. Let's look at some more. Let's look at 5 and 6. Clear my screen. Here we go. I'm feeling a little bit more in the groove now because I wasn't really happy with the number line at the beginning of the course. This is a much better number line, much better. And I will give this to you. Okay. Again, I don't care if you memorize this. You're going to have your phones. You can do this on Google. I'll show you in a minute how to do this on Google. But anyways, number 5, milliliters to liters. So milli, 1, 2, 3. I'm going back 3. So 250 milliliters, 250. Here's my decimal at the end. 1, 2, 3. Put my decimal there. So it's decimal 250 liters. Okay, let me do one more. 0.0003 745 kiloliters. You'll never see something like 6 in real life either. Okay, I want to go from kiloliters to liters. Kiloliters to milliliters. So 1, 2, 3, 4, 5, 6. All right. 1, 2, 3, 4, 5, 6. So you would get 374.5 milliliters. Whew. Not as bad now that like, is this cool? Does this make sense with everybody? I hope so. I hope so. Chat. Haha, okay. So for Asma and Lorena, yes, this is much better. And I didn't mean to like start off confusing because I just find like the book doesn't give you like the book. Hold on. Here we go. The book doesn't really give you a very good chart because it doesn't explain where's nano, where's micro, right? So no, I will give you the other table I'll give you this on a test. Of course, this part on the bottom, well, you don't need that bottom part, but I'll give you this part on the top. Now, let's just pretend, right? This is real life. You guys are going to have your cell phones with you. Ask me, it will be like this on the test. Oh, Abdullah got a different answer for that for number 6. I'll make sure I didn't make a mistake. But one thing I want to show you, and you guys probably know this, but if you were doing this in real life and you went to Google, oh, I didn't mean to go to Google Drive. Hold on. I just want to go to google.com. You know, if you want to go 250 milliliters to, let's try centiliters, Google will convert it for you. And then I can pick all sorts of things. So I could go like US gallons. I could go, it doesn't have to be liters. This could be kilograms to micrograms or milligrams, sorry. So 250 kilograms would be 2.5 times 10 to the 8 milligrams. I could change it to grams. If you were British, you could change it to stone, right? So Google can help you with this. Now, the unfortunate part is on a test, you're not going to get Google, but on a test, I will give you this. Okay, now let me check the chat, and I want to make sure I didn't make a mistake. Anybody who's had me in chemistry knows I make mistakes sometimes. So let's check number 6. Sorry. Okay, let's check number 6. I'll share my screen. I'll fix my screen in a second. Okay, number 6. Sharing my screen now. Let's check it out. I might have miscounted. Okay, so I am going from kiloliters, so K, to milli, M. So 1, 2, 3, 4, 5, 6. 6 decimal places to the right. So 1, 2, 3, 4, 5. 6, Abdullah. If I could give you a bonus mark, I would. I didn't count correctly. So this is exactly one reason why you have to be very careful. Make sure you count correctly, which I apparently didn't do. Let's try that again. Okay, let's zoom in. Oh, I can't zoom in. Hold on. I'll zoom in. Okay, let's try that again. Make sure I'm counting correctly. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep, Abdullah. 5 bonus imaginary marks to you. I can't give you real marks, but there's some imaginary marks for you. All right, thank you for that. And guys, like, you ever see me make a mistake, let me know, because it happens. It's hard to talk and write at the same time sometimes. So, you know, I'm a human. If I make a mistake, let me know. So I recommend maybe practicing some of these. You know, try the other ones, 7, 8, 9, 10. If you guys want this link, this image, I'll put it in the chat. So if you guys would like to see this image, it's here. Just check your chat. There's the image. You can save it. I'll make a post of it in the news. And let's see what else we can do. I'm pretty much done. Unit conversion. Oh, yeah. Yeah. This is my favorite method. So another method, I won't go too much longer, guys. Just give me 5 minutes. Another method from Math 1700, this is how I did it in chemistry, is to use the table to do some of these unit conversions, meaning I would multiply it by a factor. Like, let me give you an example. I know that 1 liter equals 1,000 milliliters, or you would say 10 to the 3. Okay. And I know it's different than this, but I'm just showing you how like I would do this. So if I had 2.5 liters, I would multiply this by 1,000 over 1. That's kind of how I would have done this in chemistry. We'll look at this a little bit more in detail tomorrow. Okay, you don't have to worry about this for now, but tomorrow I'm going to show you how to do this using the multiplication method. Like guys, normally I'd go for another 30, maybe 20 minutes, but I do have to get to work for a invigilation. This is my 6th exam of invigilation. The key is, guys, you can use any conversion method that you want on the test. So you can use the number line, you can use multiplication method, and I will show you this a little bit more in detail tomorrow. But after we finish these conversions tomorrow, we're going to start talking about pharmacy in or a more specific pharmacy unit. Have you guys in any of your pharmacy courses talked about CC? Have you ever heard of that, CC? Anybody, CC? You hear it in TV shows all the time. No, okay, so Abdullah says no, Dominique says no. If you watch a lot of TV like I do, as in someone, Aisha in high school, guys, and I'm not trying to teach anything new, sorry. We're going to finish this tomorrow, but just a heads up for tomorrow's class. If you watch a lot of movies or like, hospital shows, police shows, it's like, give the patient 5 cc stat. You hear this in the movie shows. A cc is a milliliter, or what we would call a cubic centimeter. This topic tomorrow, if I didn't have to leave to go to work to do something, this is so important. So make sure you come to class tomorrow. We're going to look at cubic centimeters. It's a volume, which means it typically measures liquids. So, something in a syringe, a needle, or I guess you could say something you would drink, but you would typically see this in a syringe or needle. So, yeah, like I got a private message, but this is like a real life medical situation. In chemistry, we would say milliliters. In the hospital, you would hear CC. And we're going to talk more about that tomorrow. I'm sorry that the class was so short. I'm sure you guys don't mind, but I think this was a good introduction, a good little review. And if you have any questions, let me know. This will go up on YouTube later today. Wish me luck in my vaccination. I hope I don't get, some people get pretty sick. Hopefully I don't. But yeah, have a great day, everybody. And we'll continue this tomorrow.